All right, great.
I'm the moderator of this session, but I'm going to turn this over to Catherine Roberts, who is the newly appointed leader of COMAP, having come from a serious leadership position in the American Mathematical Society. She is now working with this incredible organization, which is perhaps one of the earliest ones, founded by Saul Garfunkel a long time ago. So
Yeah, 42 years ago.
and so, Catherine, you're on. Tell us more about COMAP.
Great, excellent. So thank you so much for coming and learning a little bit about this organization. So COMAP stands for the Consortium for Mathematics and its Applications. And a giant in our field named Saul Garfunkel founded this organization over 40 years ago and served at its helm until just this past September when he retired and turned the reins over to me. So prior to this, I am a modeler myself, an applied mathematician. I've been a faculty member for about 25 years. And for the past 7 years was leading the American Mathematical Society. So this is a great opportunity to come here. It's a real challenge to follow in Saul's footsteps, but really gives us an opportunity to reflect on what's been accomplished over the last 4 decades and then what might be going forward. So I'm thinking a lot about sort of chapter 2 for this organization. It is a nonprofit organization, and we'll talk a little bit more about it now. So I first want to say something that, of course, we all very, very much know, is that mathematical modeling experiences can really provide us with, students and with all of us as opportunities to really cultivate our communication skills, our comfort level with ambiguity, our ethical grounding. And as somebody who was trained in the liberal arts, a real appreciation of the interdisciplinary and cross-disciplinary nature of this kind of work. And that has really been a focus for this organization all along. The focus of this organization is to improve math education with an emphasis on mathematical modeling. That has always been the case. Saul said his mission in life was to persuade the world that mathematical modeling was the approach to take when we are educating students, not only in the K through 12 level, but also at the undergraduate level and beyond. So a lot of the work that COMAP does is trying to help teachers at K through 16, let's say, levels, really try to address that question of when am I ever going to use this? And that's really what this organization is all about. So when you hear COMAP, you should think mathematical modeling, and you probably will also think of the contest because we run a competition that I'll tell you a little bit more about too. So we offer 5 different international mathematical modeling contests, and over 30,000 teams participate. That translates to over 100,000 students from around the world participating in our contests every year. We publish 2 journals. Consortium comes out twice a year, and that's focused more on the high school level. And then we have the UMath, the Undergraduate Math and Application Journal, that's more for undergraduate math applications, math modeling. We have a large and always ever expanding library of curricular resources, and you'll see I'll be shifting my conversation more to be an invitation because I really want to invite you to get engaged or to direct people who you know to me so that we can get them engaged in the work that we're doing. And then I mentioned one website that we run called mathmodels.org. So just to show you some of the things that we do, I think COMAP really landed on the map when they were responsible for publishing a book called For All Practical Purposes. And I remember when that came out, it's now in its 11th edition, but when that first came out, it was really one of the first options for non-STEM majors needing to take a math course at college. To graduate from the university, you have to take a math class, and the options were generally college algebra. They still are, college algebra, but this was an alternative to that. A book that looks at contemporary mathematics, that has the modeling perspective, and introduces students to things like voting methods and other kinds of real world problems. And now the market is replete with such books and such offerings, but I credit Saul and COMAP for really starting this all out with For All Practical Purposes. We have other books as well. We have a book called Discrete Math, and its 5th edition will be coming out later this year. It's a nice alternative. Take that discrete math perspective to complement some of the other courses that we have. It's appropriate for 11th, 12th grades or the first 2 years of college. We have a book, Pre-Calculus, that takes a modeling approach, and that will be coming out with a third edition again later this year. So it's just a very applied modeling book. We also have a whole series of modeling modules. If you're not going to teach a whole course, but you're teaching, say, an ODE course, and you would just like to insert a project into that course about mathematical modeling, I really invite you to go and take a look at on our website. And if you go to the resources button, these pop up right at the top. These are modules that can be done in like a class and then homework. Or if you're in high school, I mean, if you're teaching high school, maybe over the course of a week, you could complete one of these kinds of like inserted into your course modules. We have a biomath collection of 20 different modules with teacher and student materials. Again, that's very interdisciplinary. That was done in concert with DIMAX and Colorado State University. We have another one that was done with the NSF and COMAP and DIMAX, that's computational thinking. And again, has 11 modules, any one of which could be inserted into your curriculum. Just wanted to point out our just did a little images of our journals, and that one that you see for UMAP is a picture of Saul when he wrote his "Hello, I Must Be Going" editorial just recently. There's also a report that many of you may be familiar with and use, and if you're not, I encourage you. It's a free download. You can download it from our COMAP site or from the SIAM site. We worked on this together, and it's a guide to instruction for math modeling, available in Spanish too. And it's and that's why I threw that picture up of the Spanish image. But it's a really powerful guide to teaching mathematical modeling that I encourage you all to take a look at. And it's just a free download. I want to shift a little bit to our contests, because that is really a big part of our work and of our annual cycle. We run contests. There is a high school math modeling contest, brand new. This is just the second or third year. A middle school mathematical modeling contest, and those are run in November. And then in February, we actually just finished it up last week. We run a math contest in modeling that has 3 different problems that teams can choose, and an interdisciplinary math contest in modeling. There's also an international math modeling challenge that we run, where we have about 30 different countries, each put forward one team to work on a modeling problem. So the winners of our high school competition are invited to participate, in this and perhaps represent the United States at this international contest. And just down in the lower corner, I wanted to point out, we're not the only ones on this landscape of offering modeling contests and modeling challenges. SIAM runs a wonderful competition that's sponsored by MathWorks called the MC3 Challenge. That happens in the spring, and that is for high school students as well. So these contests are age limited, so you can level up to a higher contest, but you can't level down. And the size of the teams varies. For the middle and high school, you can have teams of up to 4 students, and for the undergraduate contests, it's a team of 3. And we open up the contest for 14 days in November. Students don't spend 14 days on it, but I think they're limited to so many hours once they get started in that window. To do it, they pick a problem. We have hundreds of teams participating. There's a fee of $100 per team to do this. The winning and outstanding papers do earn some prizes, scholarships, and other kinds of recognition. The MCM is our biggest competition, with 20,000 teams participating worldwide. They choose between 3 problems: a continuous, discrete, or a data problem. The work is done over 4 days. They get 99 hours to actually work on the problem. Team of 3 students, work. And again, that contest just ended on Monday. So we were thrilled to have over 30,000 teams participate this year. The interdisciplinary contest is really just an expansion pack on the MCM to bring in interdisciplinary questions. It has an OR problem, an environmental studies problem, and then also a policy problem. some contest myths, it's tricky. If you go to the mathmodels.org website, you can see all of our past contest problems. And if you pay a $30 a year fee, you can get behind the paywall and see the outstanding solutions from each of those years. And it can be intimidating if you're thinking about running a team from your school. You can be like, we can't compete with this, because some of those outstanding papers are pretty outstanding. But that's not the point. Excellent models can be created at a variety of levels, and oftentimes, almost every year, one of the outstanding teams does for the undergraduate competition does come from a high school group. So that's not unusual. We like simple models if they're clear, and if the students are quite cognizant of the limitations and the assumptions they're making, and what they would do if they only had more sophisticated tools at their disposal. It's a great team thing. The students work together. It's often, it doesn't have to be a bunch of math geeks. You need somebody who's a clear communicator, somebody who's a good leader to organize and wrangle the group. And having a lot of diverse skills is really important. Maybe having somebody who can program, somebody who knows a little statistics, all those kinds of things can help. And the problems are always engaging and really interesting. So this is sort of my pitch to faculty who might be thinking about bringing bringing their department into the contest, and running a team or two or three or whatever. Some of the real benefits are pretty clear, and I think fostering curiosity is really important. It was funny, I started here in September, so I'm letting people know, like, oh yeah, I've left the AMS, I'm over at COMAP now, and so many people go, oh my gosh, like I did that when I was an undergraduate, like I did that contest, and they think favorably about that. That was a kind of a fun marker of a neat thing that they did over a crazy couple of days when they were undergraduates. This is one of my very favorite best jobs lists that's out there. It's put out by an organization called CareerCast, and they take a funny view and a unique, I think, perspective on ranking the best jobs. They consider the work environment, like where is it a pleasant work environment? They consider the income potential for those positions. They look at the job outlook, like are there going to be jobs going forward in these areas. And then they also look to where the stress is minimal, where you have the least amount of stress. That's kind of my favorite thing about this. So doctors and lawyers might have, good job output and, great income potential, but lots of stress. So those jobs aren't going to appear on this list. And if you take a look at the list of the top 10, the last time CareerCast came out was 2021. Take a look at those top 10 jobs. We're all over that. We're all over that list. So this is kind of one of those favorite slides that I insert whenever I'm giving any kind of presentation. And the last time it was like in 2005 was the last time I had looked at this. And at that time, actuary was #1. So it's dropped to #9. As we see, we've been bringing in like genetics now, and more data science is kind of is emerging as a favorable job. So here's my invitation to you all, and I hope we can spend the last few moments just chatting or asking questions. I really want to invite you to join COMAP. It's free. There's a free option for educators and students that gets you behind that paywall and gets you access to all of our materials. A lot of the materials are already free and open to everybody anyway. A nice thing to consider if you are on any social media would be just search for COMAP and follow us, whatever you're on, LinkedIn or Twitter or Facebook or whatever, because that's a nice place where you can see our blog posts. We put out a couple blog posts every week, featuring neat mathematical models, new papers that have come out, news stories and things. You can join mathmodels.org, that website that has even more extensive resources, and it is contest focused for $30 a year. We'd love to have you become a team advisor for our competitions. You know, these competitions have gone absolutely viral in China. You know, pretty much every undergraduate math major who's planning on further study in mathematics participates in this competition. It's considered a rite of passage in China, but it has not gone viral in other parts of the world. So wherever you are, we'd love for you to we'd love to seed you and try out having a team in your area and see how it goes for you. We're also always looking for triage judges. So we have 30,000 papers that just got poured into COMAP this week, and we need to figure out which one of those papers are outstanding papers, and that's a big endeavor. So we have hundreds of triage judges. We pay them $10 a read. Every one of those 30,000 papers gets at least 2 triage reads to help us bin those papers and determine which papers will go forward to the final judging round that will happen in April. So we're always looking for triage judges. We'd love to have you sign up. We're always inviting writers to write papers for our journals or to help us write and create new curricular materials. A lot of, you know, I mentioned that Saul has retired and our in-house writer just retired. And there's another person who's done an awful lot of writing for us who's probably going to be retiring in the next year. So there's a real turnover happening right now. So we are looking for creative people who have ideas, who want to write modules, who want to help us write, you know, all kinds of different pieces of curriculum. Right now we're working on a project with with various states across the nation to write curriculum for high schools, including little mini tasks that teachers can plop into their existing classrooms and whole units of curriculum at the high school level is an active project that we're working on right now. So I'm going to stop sharing my screen and say thank you very much for coming. I know I went through that quickly. But I just wanted to, and I appreciate that you came. I appreciate that you came to hear a little bit about this organization. It's a scrappy organization. It's proud to be a disruptor kind of an organization. It's also maturing now. So, you know, it's a partner in the joint math meetings now, and COMAP has a seat at the CBMS, the Conference Board of Mathematical Sciences now. So, you know, even if in the past it was sort of a disruptor, and we hope to continue that disruptor mode, but we do have kind of a seat at the table now to help drive conversations about math modeling and its importance as we are educating and advancing mathematics.
Well, thank you, Catherine. We have some time. And I think she's absolutely right. A number of alumni will come back to your school, and they will not tell you how exciting the lesson on integrating factors was. They just won't do that. But they will come back and go, do you remember that weekend you threw us in a room and put some M&Ms every once in a while, and we did this crazy modeling competition? They will not forget that.
That's right.
Nor will they forget the impact on their growth as appliers of this mathematics that we've all been teaching them. I think all of you are in the choir on that regard, but it's good to remind ourselves of that. Mm-hmm. And one other thing is some of these kids participate and they do it once and that's fine. And others do it for several years. When I was at West Point, I had a woman who was on a high school team and she was outstanding. And I thought, great, we'll get her amongst all of the teams. And when she came to my office, she basically said, been there, done that. And that was great. Then we had another group of kids who started as first-year students and progressed through the award level until they were juniors and got the top award. And then they began to be influences of other kids. So once you begin this at your campus, it will grow. And the model...
Yeah, my son went to there's a magnet school in Massachusetts that's just for 11th and 12th graders at Worcester Polytech, WPI, and it's called like Mass Academy. And when he was a student there, he's now like 28, but when he was a high school student there, they just started doing the MCM. And I was like, oh, you know, I'd been a past judge of that. So as a parent, I volunteered to go in and give kind of like, you know, secret pointers from a prior judge for the competition. They were just starting, and I think their first year they were like successful participants or something, like not, they didn't do well. And then this year, they were an outstanding paper. So that's what happens. The team advisor over time gets a better sense of what we're looking for, and cultivates these teams that gear up. And also when my son was there, they only ran maybe 3 teams, and now the whole school runs. Like everybody has to do it, and they had an outstanding team this year. So yes, it's something that grows over time and gets better and better. And this year at the joint math meetings, there was a session about the math contests, and a group of 3 kids from Columbia University came and talked about their experience. And that team of 3 had done the contest 3 years in a row. And then that 3rd year, they were an outstanding team.
Catherine, you need to be corrected. That was not a team of undergraduates. Those were 10-year seasoned PhDs in mathematics, neuroscience, and a whole bunch of other things.
Oh, yeah.
Who gave an amazing, amazing talk. If you didn't see it, you really missed something. And there are lots more like them. And as Catherine said, there are kids who just get in at the start. It's the participation that they remember, the richness, the searching, the building, the critiquing, and so forth. When I was at West Point, the cadets would get extended leave, and they'd literally camp out in a classroom that I gave them. So they had extra incentives, they had freedom, and they could fill the whiteboards and do all that kind of stuff. And they build camaraderie because they don't always know each other well, but they, any questions or comments? Any experiences listeners want to share with having done it, or no?
Well, I'll close by just saying I really do hope that you'll check out the website, keep us in mind, volunteer if you want, have an idea, maybe you've done a cool project in one of your classes, and we could talk about maybe shaping that into a module or shaping that into an article, and anything like that would be terrific. And again, if you're a social media person, which I barely am, but you can go and follow us on social media, is also a good thing. So thank you very much, everybody.
Well, thank you, Catherine. And good luck. Good luck in your new position. Take care now.
Thank you.
Bye-bye.